Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 5, exponents, polynomials, and polynomial functions. In these sections, we're going to focus mostly on section 5.2, more work with exponents and scientific notations. I think I said notation, so which is apologize for that. I need to correct it each time. But more work with exponents and scientific notations. It's important to take a closer look. We have multiple objectives. Use the power rules for exponents. Use exponents uh, rules and definition to simplify exponential expressions. We're going to simplify exponential expressions with variables in the exponent, and we're going to compute using scientific notation. Without further ado, I think the first thing we're going to do here is to talk about the power rule. The power rule and power of a product or quotient rule for exponents. If A and B, if A and B are real numbers and M and N are integers, then power of a power, we multiply the exponent. As I recall, if you have a power m times a power n, remember we add the exponents. We covered this part already. And we said also if we have a power m over a power n, for quotient, we need to subtract the exponent. Here, as you can see, we multiply the exponent. For example, if I have x power 2 power 4, we don't add the exponent. We need to multiply 2 times 4. It's going to be x power 8. Now, for the second rules, if you have additions, product power with different base, same exponent, we can distribute the exponent. For examples, if we have 2x power 3 power 4. So what we can do, we can get 2 power 4, x power 3, power 4. So 2 power 4 is 16 because it's 2 times 2 times 2 times 2 is 16. And because for this one, we're going to multiply the exponent, going to be 12. Now, the third rules, you see it's in quotients. Different base, same exponent, we can again split it. So if we have like, 2/3, 3/4 power 2. So we can say it's 3 power 2 over 4 power 2. That gives us 9 over 16. So that's power of a quotient. So these three properties or these three rules are very important in the study of exponents. So we're going to use an examples very quick. We see for A, because we've said power of a power, we need to multiply the exponent. That would be y power 16. Here also we see 3 power 3 times 2. Remember, we need to multiply the exponent. 3 times 2 is 6. And when you do that, you're going to find a big number. For C, even though the exponent is negative, you still need to put it negative like this. 2 times -1 is -2. 6 power -2. But remember, we said the exponent should never ever be negative. So we're going to flip it. It's going to make it 1 over 6 power 2 is 1 over 36. And this one, remember x power -5 times -7, two negative in multiplication become positive 35. So both negative, when you multiply them, it's become positive. A second example would lead us to something because we said use the power rule to simplify each expressions. Write each answer using positive exponents only. Always express your answer in in simplest form with positive exponent. Now, this exponent right here, you see that exponent is outside of the parenthesis because that means it's for the x, and it's also for the 3. So what I can do, I do 3 power 3 times x power 4 power 3. So 3 power 3 is 3 times 3 times 3. That makes it 27. X power 4. So when we have power of a power, we multiply the exponents. So 27x power 12. For B, we can distribute the exponent because we said if the bases are different with the same exponent, we can give them each of them. 4 times 4 is 16, 5 times 5 is 25. In C, remember these exponents right there. First of all, I can do 2x power 4, and I do 3y power 5 power 4. You see, I give each of them their own exponent. Next, I must also give the 2 power 4 by itself, x power 4 power 4. You see, I distribute the exponent in the numerator, and I'll do the same in the denominator because 3 power 4 times y power 5 power 4. Now, we apply the previous properties. 2 power 4 is 2 multiplied by itself 4 times. That give you 16. Um, Power of a power, we multiply the exponent 4 times, so is x power 16 over 3 power 4. 3 times 3 times 3 times 3, 4 times, I make it 81. Y power what? Yes, 20. Now, between 16 and 81, they don't have anything in common. We're going to leave it as is. But if there was any common factor, we're supposed to simplify. If we go with D, remember that exponent is for every term in this parenthesis. The first thing is to make sure we distribute it with -5. We distribute it with x power 3. We distribute it with y power 2. We distribute it with z power 4 power 2. Now, -5 power 2 gives you 25. X power 6, y power 4, and z power 8. Remember, why we said 25 is because, remember, -5 times -5. Remember, -5 power 2, we have two negatives become positive. So don't forget this, very giantly important. Now, how we can use exponents rules and definitions rule to simplify exponential expressions. We have a variety of rules that we already covered so far. Product rules, when we have the same base, we add the exponent. Power rule, power of a power, we multiply the exponent. Product of a power of a product, different base, same exponent, we distribute the exponent. Power of a quotient, different base, with the same exponent, we distribute. Know that the denominator cannot be equal to 0, otherwise it would be undefined. Quotient rule for exponents, same base, we subtract the exponent. Remember, a cannot be 0 here. We also covered, any non-zero number power 0 is equal to 1. We said negative exponent. I strongly advise you to take a screenshot of this of this slide and save it because this is the summary of all rules we're gonna cover so far. I mean, we will continue to use them even in the next examples we have here. For the first one, the first thing to do is to distribute the exponent to each term inside of the parentheses. We're going to have 2 power negative 2. We have x power 0 power negative 2, y power negative 3 power negative 2. Okay, remember, if we have, for me, it's the same thing having 2 power negative 2 like this. Remember, any non-zero number power 0 is 1, so we're going to have 1 power negative 2, okay? And then we're going to have y power -3 times -2. Over here, this will change 1 over 2 power 2. Okay, remember, we know this one's gonna be 1, but look, 1 power 2. You see, 1 power any number would always be equal to 1. Now, 2 negative become positive, y power 5. Let's simplify. We know the final answer, oh, sorry, 6, because we multiply. So it's y power 6 over 4. And that would be the final answer. If you want to take a time to review it, do not hesitate to pause the video. But if you go with the second examples, again, the first thing is to distribute the -3 to the numerator and to the denominator. That's the first thing to do. Second thing is to multiply because it's power of a power, -5 times -3, -2 times -3. Now, it gave us 2 negative give you +15 over x power 2 negative give you +6. We're not done because now we realize the bases are the same, x, so we can subtract the exponents. It gives x power 15 minus 6. This is x power 9. Final answer. So those are some great examples, but our goal is to do as many examples as possible. We can even go with 6, 7, and 9, and 10, but if we go with this one, because they ask us to simplify each expressions, we write each answer using positive exponents only. Remember the goals here. Two ways we can do that. We can distribute the -2 power -2, 5 power -2. Now, because the exponent cannot be negative, we're going to bring the 3 power -2 to the denominator and bring the 5 power -2 to the numerator. So we have 5 power 2, 3 power 2. So answer would be 25 over 9. Other ways you could do this one also, once you see the exponent negative, you could flip the inside and make the exponent positive. You see, it's still the same thing. 5 power 2 over 3 power 2 is 25 over 9. Now, for this one, all we need to do is to make sure we bring every terms on the right place. As I see these two, I can keep y power 10 minus -6 on the top. I bring the 6 power -2 to the bottom because it's 6 power 2 times x power 2. Remember, I bring this one to the bottom. It's going to be minus -4. Okay, so I bring all the x's to the bottom. The reason why I do that is because it's going to help me to keep the exponent positive. Now, you see -6, so that would be y 10 plus 6. 6 power 2 is 36. If it was in the numerator, I wouldn't be able to do it. Okay, I wouldn't be able to do it. And we have x power 2 plus 4. So we have y power 16 over 36 x power 6. And this is the answer. As I said, we have so many examples we can do to help you better understand this section because you're going to have a lots of examples to do on your own, before you can complete the assignment. So here again, we have the exponents that we can distribute. Two things we can do. We can just flip the inside if we want, okay? If we want to do it, we can flip the inside, or we can solve the inside using our PEMDAS, like we have 4a power 3, b power 2 minus -6 over C, because I don't need to bring C to the top because C doesn't bother at all. I don't have anything to simplify. Remember, it's power -2. Now, again, I still have 4a power 3, b 2 plus 6 over c, again, exponent -2. I don't change anything yet. That gave me 4a power 3, b 8 over c power -2. Now, after I do that, I can definitely distribute the negative. I can do 4 power -2, a power 3 power -2, b8 power b power 8 power -2, c power -2. Simplify for b and a. So 4 power -2, a power -6, b power -16 over c power -2. Remember the rule, never keep your exponents negative. What we can do here, we bring the c power 2 to the top, make it positive, but 4 power 2 denominator, a power 6 positive, b power 16 positive. What is 4 power 2? 16. So 2 c power 2 over 16 times a power 6, b power 16. Yay! I think we do it because we have so many examples to do in these sections. If you look at the next one also, we have so many examples. Here, what we can do also, as we said, I'm going to do a different ways for you. We're going just to flip the inside, bring the denominator to the numerator and the numerator to the denominators. Remember, if you flip it without changing the sign, do not change the sign. If you do that, you would do power 2. Okay, we can do that. We do, you know what? Let's just do it this way. Negative, I mean, not to negative 3 power -2 power -2, a power 3 power -2, b power -2. Let's go with the bottom part. 3 power -4 power -2, because I will give each of them their own. A power 7 power -2, b power -3 power -2. You see, I distribute the common exponents to each term inside of the parentheses. 2 negative give me positive. That means 3 power 4, a power -6, b power -2. We have 3 power 8, a power -14, and b power 6. Okay, remember we need to multiply the exponent when you have power of a power. Now, again, remember we can simplify as much as possible. The first thing we can simplify, okay, if we want to simplify this, we bring each term where it's going to be positive, negative. First of all, if you want to keep 3 power 4, a power 14, I bring the a power 14 to the top, and then I do b power -2. We're going to bring the b power -2 to the bottom. Okay. Now we're going to have 3 power 8, b power 6, b power 2, and a power 6, because I said we bring this to the bottom. What you can see, 3 power, can we simplify a little bit? You know what? I'm not gonna do that. Make it, I want to make sure you see what we're doing. We're gonna do what we've been doing so far, then we can simplify. 3 power 4 minus 8. Okay, we subtract the exponent. We're going to have a power negative 6 minus negative 14. We're going to have b power negative 2 minus 6. Let's simplify. 3 power negative 4 because 4 minus 8 is negative 4 times a minus 6 plus 14 b power negative 8. We end up with um, 3 power negative 4 times a power 8. Okay, we're going to have a power 8. And then we have b power negative 8. Now, bring all with the negative exponent to the denominator. We have a power 8 on the top, 3 power 4, b power 8 at the bottom. So we know what is 3 power 4 is 81. A power 8 over 81 B8. Okay. Yay! I think we did it. That's how it's supposed to be. Okay. That's how it's supposed to be. There are so many other examples we could do, but I'm hoping you get this one correct because what they ask us, for example, simplify that a and b are integers and that x and y are not zeros. So you see here also, um, that exponent is not for the one outside. It's for here and here. So we have x power negative b, 2 power 2, x power b power 2. So we have x power negative 1b times 4 times x power 2b. Remember, negative 1b, 2b, the 4 stay 4, but we're going to have x power 2b minus 1 or plus 1, plus 1b. Okay? So this gives us 4x power b. Final answer. Here also, we see we need to multiply power of a power. Remember, these two, we need to multiply them over y. Here, there are two ways you can do that, okay? You can see that you have a times y power negative 6. So, because that's a certain way to get rid of all of this if we want. But if you don't want to do that, we're going to keep it the way it is. Like, you see, I tried to show you different ways of doing this same thing. So we're going to have y power 6a over y power a minus 6. Now, what we can do, remember that, we can do y same basis. We have 6a minus a minus 6, y 6a minus a plus 6. So 6a minus a is what? Yes, 5a. Y 5a plus 6, that would be the simplified form of that exponent. Yay! Probably you like it. Probably you enjoy it because our goal is to continue to do more examples in this format, but also we can compute some scientific notation like multiplying and dividing with numbers written in scientific notation involves using properties of exponents. To perform operations on numbers written in scientific code, we use properties of exponents, so we can do that like this one. First of all, we have so many different ways we can write that. The first thing is to multiply the bases together. So when you multiply 7 times 3 times 8.1 times, remember for 10, you have 10 power -2 times 10 power 5, right? In a cal if you use a calculator that unfortunately, let me see if I can find a calculator very quick. I can do in my calculator 7.3 times 8.1. It gives me 59.13. But for the exponent, remember it's gonna be -2 plus 5, give you 59.13 times 10 power 3. Now, do you believe you're done with that? Do you think we're done? No, we're not done with it. Because if in this case, what they ask you to do, perform the following operations. We can either leave it like this or write it totally multiplied by the 1000, right? Or we move 3 units to the right. This is the decimal point, 1, 2, and add a different one, that would be a 0. So we can say it's 59130. Okay, that's the answer here. Now, the next one, we see, first of all, we can perform the divisions differently. For example, we can do 1.32 divided by 4 times 10 power 4 over 10 power 9. So when we divide 1.2 by 4, it gives us 0.3 times 10 power, what again? 4 minus 9. So it gives me 0.3 times 10 power -5. Remember what's happened with -5? We move 5 digits to the left because the exponent here in the 10 is negative. So moving 5 digits to the left, 1, 2, 3, 4, and 5. So that means this is the 0. We're gonna put another one, another one, another one, and another one. So answer would be 0.00003. That would be the answer in decimal notation. I hope you enjoyed these sections again. In a different video, we will come back with section 5.3, polynomials and polynomial functions. Let me know if you have any questions. I'll be happy to answer. Take care.